Okay, so all the rules are still the same. You got to have all the same basic information memorized by the time we're done with this handout. So some of that includes plugging in 0 for x and solving for y if you're looking for x-intercept. Knowing where the numerator equals 0 and where the denominator equals 0 helps you with holes, vertical asymptotes, and x-intercepts. If any number makes both 0, you get a hole. If any number makes just the numerator 0, that's an x-intercept. And if there's any numbers that make just the denominator 0, it's a vertical asymptote. So yeah, sometimes the factoring is a little bit harder, but I mean, that's almost half the things we asked for right there. So very, very similar definitions, but one tiny little difference between each one makes them measure something different. Okay, your domain, you could plug in any x value you wanted to except for -3, because -3 was division by 0. So you could do the numbers less than -3, and you can plug in the numbers bigger than -3. Make the number line, show that -3 is the number you have to be taken out because it's division by 0, and then you can visually see the first part of your domain and the second interval of your domain. Okay, horizontal asymptotes, you've got to compare the degrees. If the degree of the denominator is bigger, it's y equals 0. Degree of the numerator is bigger, it doesn't have one. And if the degrees are equal, like this one, you do y equals leading coefficient over leading coefficient. So y equals -1/2. And finally, slant asymptote is usually the most work. This is where you have to do long division, but ignore the remainder, but only if the degree of the numerator is 1 bigger than the degree of the denominator. So most don't have a slant asymptote. Of course, on the test, we will make sure that we pick one out that has one, at least one, so we can see if you know how to deal with that. So if we throw all of this onto our graph should be pretty close to being finished. There should be no conflicting information, like it can't be an x-intercept at -3 and a vertical asymptote at -3. Like, you can't be doing two things at once. Each x value can only do one thing at a time. Asymptotes get graphed as dashed lines, and then we end up with this. So again, I always encourage you to do more points, especially if you feel unsure about some of this stuff. You know, if you plug in 3 for x and it gives you a value of 8, and then that doesn't make sense with everything else you've got going on, then that tells you, hey, I need to check some stuff. Something's off here. So that's why more points is never a bad idea. But to finish up, all graphs are going to approach either the horizontal asymptote or the slant asymptote at the end of the graph. And then every vertical asymptote is going to spike, so up to infinity on one side and down to -infinity on the other side. And so I need to see a little bit of direction here to know this one's going up and this one's going down. And nothing seems to conflict with each other, so I'm pretty confident in that answer. Although, of course, if you had a calculator, which you do in your practice, just not on the assessment, you could graph it and compare your graph to the calculator's graph. They look the same. That doesn't confirm everything's correct, because like your calculator doesn't do a good job of showing holes and stuff. But if it looks the same, then that's going to confirm that most of it's correct, and it's probably fine to move on.